Hello everyone, welcome to the Simple Spark YouTube channel. Today we are diving into the next part of the light chapter where we will explore sign convention, the mirror formula and how to solve numerical problems step by step. So let's get started. To solve mirror and lens numerical problems correctly, we need to follow the new Cartesian sign convention. Here, the principal axis is treated like x-axis and light is assumed to travel from left to right. All distances are measured from the pole of the mirror. If the distance is measured in the direction of the incident light, it is considered positive. If measured against the direction of light, it is taken as negative. Also, any height measured upward from the principal axis is positive, while height measured downward is negative. This rule helps us maintain consistency when applying formulas in ray diagrams and numerical problems. This rule chart gives us a clear idea of when to use positive or negative values in mirror problems based on direction and position. When an object is placed to the left of the mirror, the object distance u is taken as negative. If the image forms on the same side as the object, which happens in concave mirrors for real images, the image distance v is also negative. Focal length f is negative for concave mirror and positive for convex mirror. If the image is above the principal axis, height is positive. If the image is below, it's negative. Distances measured in the direction of incoming light are positive and those measured opposite to the light direction are negative. Object distance u is always taken as negative because the object is placed in front of the mirror on the left side opposite to the direction of incident light, and the image distance depends on where the images is formed, because sometimes the images will be formed to the left side of the mirror or sometimes to the right side of the mirror. So if the image is real and formed in front of the mirror, that is to the left side, then image distance, that is v, is negative. If the image is virtual and formed behind the mirror, that right side of the mirror, then v is positive. What about the height? Height of the object, or it is sometimes denoted as h naught or sometimes it is denoted as h, is always positive because the object is always placed upright above the principal axis. Because the object is always placed upright above the principal axis. Height of the image, hi, or sometimes referred as h dash, depends on the image orientation. If the image is inverted, that is formed below the principal axis, height is negative. If the image is upright, formed above the axis, height is positive. The mirror formula is a key relation in optics that connects the object distance, image distance, and the focal length. It is a relationship between v, u, and f. So the mirror formula can be written as 1 by f is equal to 1 by v plus 1 by u. This formula applies to both concave and convex mirror. By using this formula along with the sign convention, we can find the position of the image or the focal length if any two values are known. So we can understand the terms. So consider the image here. F is a focal length, V is the image distance, and U is the object distance. So they all are measured from the mirror only. So the f is a focal length, that is distance from the pole to the focus. And what about the image distance? Image distance is nothing but distance from image to the pole. And what about object distance? Object distance is the distance from the object to the pole. Next is about the magnification. Magnification is the ratio of height of the image to the height of object. It is given by the formula magnification m is equal to hi by h naught, or we can consider h dash divided by h, where hi or h dash is height of the image, h naught or h is height of the object. Magnification is also related to the object distance u and image distance v, and it can be expressed as m is equal to hi by h naught is equal to minus v by u. The height of the object h naught is positive because the object is usually placed above the principal axis. The height of the image hi is positive for virtual images and negative for real images. A negative magnification means the image is real, that is real and inverted. A positive magnification means the image is virtual, that means upright. I hope you understand the mirror formula and sign convention rules. Now let us solve some of the problems related to it. Consider the first one. The radius of curvature of a spherical mirror is 20 cm. What is its focal length? First, let us consider the given terms. The radius of the curvature R is 20 cm and it is 20 cm, and radius of curvature of the spherical mirror is 2 times focal length, that is 2f. So we know that the relation between radius of curvature and focal length is R is equal to 2 times f. So f is equal to R by 2, 20 by 2, that is 10 cm. Next is find the focal length of a convex mirror whose radius of curvature is 32 cm. So here the mirror is clearly mentioned as convex mirror. We know that for the convex mirror, radius of the curvature or focal length will be positive one because it is appear to the right side of the mirror. So R is equal to 2f, f is equal to R by 2, 32 by 2, and it is 16. So the focal length of the given convex mirror is 16 centimeter. Next one, a concave mirror produces 3 times magnified, that means enlarged real image of an object placed at 10 centimeter in front of it. Where is the image located? So now we know that the height of the object will be considered as h. It is clearly mentioned that it produces 3 times magnified real image of the object. That means hi, that is height of the image, we can consider as minus 3h. Why it is minus? Real image. So the real image is always inverted image. So it is considered as the height of the image is minus 3h. So m is equal to hi by h naught is equal to minus v by u. That is magnification formula. So substitute the values of hi and h naught. Minus 3h divided by h is equal to minus v divided by u. So we will get v by u as 3. Object distance u is equal to minus 10 centimeter. So by substituting the value, we will get v is equal to 3 into minus 10 is equal to minus 30 centimeter. Here the negative sign indicates that an inverted image is formed at the distance 30 centimeter in front of the given concave mirror. Next one. Radius of curvature of a concave mirror is 25 cm. What is its focal length? So here the given mirror is concave mirror. For the concave mirror, the radius of the curvature and focal length is negative. So it is given that r is equal to f by 2. F is minus 25. Minus 25 by 2 is minus 12.5 cm. The negative sign means the focus lies in front of the mirror, which is true for concave mirror. So the focal length f is negative for concave mirror according to the Cartesian sign convention. Next problem. A concave mirror produces 10 cm long image of an object of height of 2 cm. What is the magnification produced? So here clearly given the image height and object height is given. Image height is minus 10 cm and object height is 2 cm. So why here image height is minus? Because the concave mirror here produced the real image. So m is equal to hi divided by h naught. Substitute the values of hi and h naught. Minus 10 divided by 2, that is equal to minus 5 cm. Magnification is negative, indicating the image is inverted. The image is 5 times larger than the object. Next one. We wish to obtain an erect image of an object using a concave mirror of focal length 15 cm. What should be the range of distance of the object from the mirror? What is the nature of the image? Is the image larger or smaller than the object? Draw a ray diagram to show the image formation in this case. So the concave mirror gives a virtual and erect image only when object is placed between its pole and focus. So if the object is in between pole and focus, then only it will give the erect image, that is virtual image. Hence, the range of distances of the object should be less than 15 cm from the mirror, so that the image is virtual. Image is larger than the object. So the ray diagram for this is, so when we keep the object in between focus and pole, we will get the image backside of the mirror. Next one. A convex mirror used for rear view on an automobile has a radius of curvature of 3 meter. If a bus is located at 5 meter from this mirror, find the position, nature and size of the image. So here the mirror is convex mirror, so the radius of the curvature and the focal length will be positive. Radius is given as 3 meter, so the focal length is f is equal to r by 2, that is 3 by 2, that means 1.5 meter. Using the mirror formula, 1 by f is equal to 1 by v plus 1 by u. Rearrange the formula to find v, because here we want the value of v. So keep the 1 by v as it is and take 1 by u to the other side. So when in addition or subtraction, when the positive value taken to the other side of the equal symbol, then it will become negative. So 1 by v is equal to 1 by f minus 1 by u. So 1 by v, substitute the values of f and u. So f is 1.5 and u is minus 5. Why it is minus? Because object distance is always negative. So by substituting, here we have the decimal point, right? So it is very difficult to take the LCM. So just make it a whole number. So multiply both numerator and denominator with 10. So we will get 1 by v is equal to 10 by 15 plus 1 by 5. By taking the LCM as 15, we will get 10 plus 3, that is 13 by 15. 1 by v is 13 by 15. Then what about v? Take the reciprocal, that is 15 by 13. The answer will be 1.15 meter. The image is 1.15 meter at the back of the mirror. So then find out the magnification. We have the formula for magnification as m is equal to h dash by h is equal to minus v by u. So substitute the value of v and u. Here already minus is there and u value is minus, so minus divided by minus will be cancelled, so you will get 1.15 divided by 5, so the value will be 0.23. so we can say the image is virtual, erect and smaller in size by the factor of 0.23. Next problem, an object 4 cm in size is placed at 25 cm in front of a concave mirror of focal length 15 cm. At what distance from the mirror should a screen be placed in order to obtain sharp image? Find the nature and the size of the image. So here what are given? The height of the object, that is 4 cm, object distance minus 25 cm, focal length minus 15 cm. You have to find v and h dash. So here the object distance is negative and also focal length is negative. Why? Because it is a concave mirror. Use the formula 1 by f is equal to 1 by v plus 1 by u. So now we want the value of v, so keep the 1 by v as it is, take 1 by u to the another side, it will becomes negative. So now substitute the value of f and u. So 1 by minus 15 minus of minus 1 by 25, so the minus becomes plus, so minus into minus will be plus, so we will get 1 by 15 plus 1 by 25. Now take the LCM of 15 and 25, it will be 75. So 15 how much is 75? 15 5 is 75 and 25 how much is 75? 25 3 is 75. So minus 5 plus 3 is minus 2. So minus 2 divided by 75. So since 1 by v is minus 2 by 75, so v is, take the reciprocal, minus 75 by 2. So the answer will be minus 37.5 centimeter. The screen should be placed at 37.5 centimeter in front of the mirror. The image is real. So the magnification formula m is equal to h dash by h is equal to minus v by u. To find h dash, we can take h to the other side, it will become multiplication. Minus v by u into h. So h dash is equal to minus of minus 37.5 divided by minus 25 into 4. So here minus divided by minus become plus. So only remaining is minus. So minus 150 divided by 25, that will be minus 6 centimeter. So the height of the image will be 6 centimeter. So the image is inverted and enlarged. Next problem, an object is placed at a distance of 10 cm from a convex mirror of focal length 15 cm. Find the position and nature of the image. So the same thing, so for what is given, f is equal to 15 cm. Here it is plus. Why? Because it is a convex mirror. Object distance is minus 10 cm and we have to find v. 1 by f is equal to 1 by v plus 1 by u. Rearrange the formula and substitute the values. Take the LCM. So 1 by v is equal to 1 by 15 plus 1 by 10. So after taking LCM we will get 30. So 1 by v is equal to 30. 15 2 is 30 and 10 3 is 35 by 30. 1 by v is equal to 5 by 30. So v is equal to 30 by 5. That is 6 centimeter. Therefore image is formed 6 centimeter behind the mirror. Image is virtual and erect. Next one, an object 5 cm in length is placed at a distance of 20 cm in front of a convex mirror of radius of curvature 30 cm. Find the position of the image, its nature and size. So here what are given, r is equal to 30 centimeter, that is radius of curvature. Since it is a convex mirror, here the radius of curvature and focal length will be positive. Height is 5 centimeter and object distance is minus 20 centimeter. Write down the mirror formula. 1 by f is equal to 1 by v plus 1 by u. Find f value, that is r by 2, 30 by 2, that is 15 centimeter. Substitute the values of f and u. So you will get 1 by 15 plus 1 by 20. Taking the LCM of 15 and 20, it will be 60. So 15 4 is 60 and 23 is 60. So 7 by 60. So therefore v is equal to 60 by 7, that is 8.57 centimeter. The image is formed behind the mirror at a distance of 8.57 centimeter. Hence the image is erect. M is equal to h dash by h is equal to minus v by u, that is magnification. So find h dash using minus v by u into h. By substituting the formula and the calculation, we will get height of the image as 2.14 centimeter. So another problem, an object of size 7 centimeter is placed at 27 centimeter in front of a concave mirror of focal length 18 centimeter. At what distance from the mirror should the screen be placed so that sharp focused image can be obtained? Find the size and the nature of the image. Given height of the object as 7 centimeter, object distance is minus 27 centimeter. So the focal length, that is minus 18 centimeter because it is a concave mirror. Write down the formula. 1 by f is equal to 1 by v plus 1 by u. Rearrange the formula. 1 by v is equal to 1 by f minus 1 by u. So minus 1 by 18 minus of minus 1 by 27. So now minus into minus plus. Minus 1 by 18 plus 1 by 27. By taking the LCM, we will get the LCM as 54. So 18 3s are 54 and 27 2s are 54. So we will get 1 by v as minus 1 by 54. V is equal to minus 54 centimeter, that is reciprocal. Find the magnification. The formula is h dash by h is equal to minus v by u. H dash is equal to minus v by u into h. Substitute the values of v, u and h. So we will get the answer as 14 centimeter and and with the negative sign. So the image is real, inverted and enlarged. So we should always remember that for concave mirror, the radius of curvature focal length will be negative, and for the convex mirror it is positive. And also if the height of the image is negative, then it is real image, real and inverted image. If the height of the image is positive, then this is erect and virtual image. So what we have learned? So we learned the sign convention, that is Cartesian rules, like distances measured from the mirror's pole. Left side is negative, right side is positive. Heights above axis positive, below negative. And mirror formula is 1 by f is equal to 1 by v plus 1 by u. F means focal length, that is distance from focus to pole, and v is image distance, the distance from image to pole, and u is object distance, the distance from object to pole. So magnification m is equal to hi by h naught, or we can consider h dash by h, that is equal to minus v by u. So v is image distance, u is object distance, ho is image height, and ho is object height. If m is greater than 0, the image will be virtual and erect, and if m is less than 0, it is real and inverted. Thank you for watching. Don't forget to subscribe for more videos. In the next part, we will learn about the refraction of light. Stay tuned. Thank you.